All right, so section 3.3 is about graphing these linear inequalities again. And sometimes they're going to be absolute values. Don't freak out. It'll be fine. So first, let's go ahead and graph these lines. The first one, we need to get it in slope-intercept form. So you have x plus 2y is less than or equal to 4. Subtract x from both sides. 2y is less than or equal to negative x plus 4. Divide by 2. You do not need to flip the sign because we didn't divide by a negative. So that would be negative 1/2 x plus 4. Let's go ahead and graph this line. Go up to 4. Slope is negative 1/2, so down 1 over 2. And then this will be a solid line. And then the next line. Oh, we got to do our shading. I almost forgot. So the shading on this one, if it's less than or equal to, you're going to shade below. So there's that, shaded. The next line, we don't have to convert it because it's already in slope-intercept form. So we have a point at negative 1. Slope is negative 1, so down 1 over 1. And this one is also going to be a solid line. My lines are rough today, but it's fine. Okay, and the symbol is greater than, so we're going to shade above it. Okay. So the answer to these problems is a region. So in this case, it's the region where both of them are shaded. Both regions that are shaded, so it'd be right in here. So that means that you could pick any point in that region and plug it into both inequalities and it would work. It would be accurate. Okay. Let's do another one. We have to convert the top one into slope-intercept form. So this one looks like an easier one. Add 3x to both sides. Y is less than 3x plus 4. Go ahead and graph it. Oh, this is a dashed line. So 4, up 3 over 1, up 3 over 1. Dashed line. And then less than, so if it's less than, we're going to shade below it. So all of this. The other line is going to be y is greater than x minus 3. So go to negative 3 and your slope is positive 1. And then this is also a dashed line. And since it's greater than, we're going to be shading above it. Oops. And so the answer to this one would be that region where both colors are shaded. Not too bad, right? Okay, so now let's throw some absolute values in there. Don't freak out. It'll be fine. So let's first graph the line. So y is less than or equal to negative 4/3 x. So the y-intercept is 0. Slope is negative 4/3, so down 4 over 3. And it is a solid line. Let's try that again. In which direction are we shading? Well, it's less than, so we're going to be shading below. Okay. The next one, or the absolute value equation is y is greater than or equal to the negative absolute value of x. So remember, that's going to be flipped upside down, and it is a solid line. The vertex is at the origin. And here we go. And we are shading above because it's a greater than symbol. So if we shade above, it is all this region. So any coordinates that would satisfy both of the inequalities would be over there on the left in both colors. Let's do another one. So we have y is less than negative 1/3 x plus 1. So let's go ahead and solve this. We've got positive 1, oops, down 1 over 3. It's a dashed line. And we are shading below it because it's less than. All right, let's change this absolute value. I'm going to change this problem. Let's make it y is less than or equal to 2 absolute value of x minus 1. So this means that it is a stretch of 2, and then it is a shift. If it's minus 1, that would be right 1. So let's graph that, and it's a solid line. So you shift it right 1, and this stretch is 2, so the slopes are 2 and negative 2. And it is a solid line. Oops. And the region that you're shading is less than, so below that. And that is all you have to do. Last one, we have the line. Y is greater than negative x minus 5, so go over to negative 5. Down 1 over 1. Solid line. Okay, this absolute value graph is doing all sorts of stuff. So it's a reflection because of the negative. It's a stretch by factor of 3. And then it's a shift. If it's plus 3, that would be left 3. And then plus 1, it would be up 1. There's a lot going on here. Oh, I forgot to shade that line. Let's shade that line really fast before I forget. So y is greater than negative x minus 5, so we're going to be shading above it. All right, now back to the absolute value graph. So go shift left 3, up 1. And then it's a reflection, so it'll be flipped upside down, and the slopes are going to be 3 and negative 3. And then don't forget, it is a dashed line. And it is a less than inequality, so we're going to be shading below. So the only area in this that would be work for satisfy both of those equations is this one right here, that little area. And that is it for this lesson.